Now it says it's recording. So next example, you guys still can see the problem on the slide, hopefully. Keep clicking on other stuff and I don't know what it does. So I have an aldehyde here and it's nice propyl alcohol again this time. So I need to make the hemiacetal from this. Again, you look at different parts. I have these 3 carbons here that are part of my aldehyde, and these 3 carbons here that are part of my alcohol. When I draw a hemiacetal, I just need my carbons up to the carbonyl carbon. Again, I keep focusing on that one because that's the one that ends up connected to 2 different oxygens. So I'm going to have an oxygen up here. I'm going to have an oxygen here. One of those 2 oxygens is actually going to be a hydroxyl group. The other one is going to be attached to your alcohol carbons. So I'm actually done with that one already. That makes sense to you guys? You had that answer before, hopefully. If not, that's all right, because we can do more examples if you didn't know how to do it already.
Okay. Yeah. Where'd it go?
But again, it's actually just as soon as you start recognizing what pieces are supposed to be what in a hemiacetal, right? If I added carbons to one side or the other, if I wanted to add 3 carbons right here, I just have to add 3 carbons right here. It doesn't really matter. As long as I understand what part of that hemiacetal came from what. So the carbonyl carbon, recognize that one first and foremost every time. Otherwise, these carbons that are hanging off of an oxygen are part of an alcohol. And then all the other carbons over here were from my aldehyde originally. Again, I don't need those pink because that wasn't in there, but I'm just showing for emphasis. If I do the next one, again, it's the same thing as before. I just wanted you to redraw this hemiacetal right here. So it had 3 carbons, a hydroxyl group, and oxygen with an isopropyl hanging off of it. So again, I'm going to take part of this and part of this, and I'm going to remove the water. What part doesn't really matter. So I'm just going to assume that, okay, I'm going to take this and this hydrogen, but this oxygen is still going to be there, right? So again, I just draw everything in here minus the hydroxyl group. Now there is still an oxygen there, but that oxygen is connected to this ring. So it still needs to be connected to a ring. So I'm going to connect it to a ring. And this is what my acetal would look like. Again, I have to take out a water to make that one work because actually I am losing atoms going from the hemiacetal to the acetal. But otherwise, hopefully you're starting to see the parts that you need to see. I still have a carbonyl carbon in here connected to 2 oxygens. It's the only carbon that's connected to 2 oxygens. So I can still tell, even if I didn't know already, that my original aldehyde was a propanol. So if I go backwards, yeah, I had 1, 2, 3 carbons with a double bond to oxygen. It's definitely a propanol. So you're just building that up, tearing them back down, and rinse and repeat. It's the same thing over and over again. So looking at this example, this acetal, hopefully you can see your carbonyl carbon. There's only 1 carbon that's connected to 2 other oxygens, and that would be this carbon right here. So I know that my aldehyde is going to have 1, 2, 3, 4 carbons in it. It's going to be a butanol. I also know that every other carbon is going to be part of an alcohol. So this is 1 carbon. That's going to be a methanol. This is 1, 2, 3 carbon or excuse me, 1, 2, 3, 4 carbons, that's going to be a butanol, a 2-butanol, or a sec-butyl alcohol, however you want to call it. But which one do you guys want to remove first? The methanol or the butanol? Because it really doesn't matter.
Let's do the butanol.
So if I take this bottom part off first, again, I have to understand that there is going to be a water that comes into play. So you might sneak in a little H2O right here. So I have to break this up. So that means that I still have that orange carbon that's attached to an oxygen that's attached to, let's make it blue again, 1, 2, 3, 4 carbons. And I'm still going to have a connection here, but it's going to be connected to a hydroxyl group that for all intensive purposes came from this water. Right? One of the oxygens out of here, I used it. One of the hydrogens, there's still one hydrogen left, but that's going to end up attached to this other oxygen that went with my butanol. So still got 4 carbons, still connected to an oxygen, but again, now it's got a hydrogen connected to it. And actually, we'll talk about later which one it actually is. It just doesn't really matter for us right now. But 2 of those, these 2 hydrogens and 1 of those 2 oxygens, it doesn't matter which one, we were assuming it was this one, are from my water. Everything else was already in that hemiacetal. So you should have a product that looks like this to start. And then you break it down a little bit further. Again, I'm going to try and remove the methanol part of this now, the orange piece. So then I just redraw pieces right down here. I'm going to have still a 4 carbon chain with my carbonyl carbon that now instead of a single bond is going to have a double bond to an oxygen. Now it's an aldehyde like it's supposed to be. But that hydrogen is going to end up attached to this oxygen. And again, since we're using color, it's a little easier to keep track of stuff that way. I also have this methanol product here. Again, I didn't have to bring in a water because everything's already there. All the atoms are already there. I just had to move a hydrogen from this oxygen to that oxygen. That's why it's blue with this orange here. And then that's it.
Will that butanol be in our answer too? Then should we put a plus with that, or do we just leave it up there?
Oh, it's still in there.
Okay.
Like I said, your final product, you actually have all of these things. You have this, this, and this. You should end up with 3 different things, 2 alcohols, 1 aldehyde. But what I'm essentially saying, like when I'm talking about this, I can just draw a random connected thing right now. So let's say I have the oxygen there, an oxygen there, a carbon here, put a couple extra carbons on here. It doesn't really matter what it looks like. What I'm saying is, if I look and I find my carbonyl carbon, and just like we were just talking about, I know that these carbons are part of the aldehyde, I could skip a step and just go ahead and draw a butanol. I could go, I already know that's what I'm going to end up with. So I can just draw that in to start. And I could, okay, I see 2 carbons here. I can go ahead and draw in, well, that means I'm probably going to have an ethanol. And I can already see these 3 carbons here. I know that I'm going to end up with an isopropyl alcohol. You could jump right to this step over here. Again, there's kind of plus signs in between those things, whatever. But those are my products when it's all said and done. I just skipped over the hemiacetal step. You can actually do that on the test if you want. I just don't want you to do that to start because I don't want you to miss and not be able to recognize what a hemiacetal looks like.
Okay.
Because I might ask you to just make a hemiacetal on the test, right, out of an alcohol and an aldehyde. And I might give you a hemiacetal to start and have you add an alcohol to it or remove an alcohol from it. So I could start you in the middle somewhere too. So that would look more like this because again, you always have that carbonyl carbon that's connected to two different oxygens, and then probably a couple carbons. It actually technically doesn't have to be connected to any carbons, but let's make it look like this. And then these, now the difference would be one of those things is a hydroxyl group, the other thing is an alcohol. So you should be able to see when you look at this thing, okay, my carbonyl carbon right there, it's connected to an oxygen and a hydroxyl group. That hydroxyl group is how you know that this is a hemiacetal and not an acetal. Does that make sense?
Yes, that makes sense. I get it now.
Okay, so now I'm just, okay, if I wanted you to break this up, you got to know that there's all these carbons here, including that carbon right there. So it looks kind of funny, but that just means I have like a 1, 2, 3, 4 chain, and it's got an extra carbon hanging off of the second carbon, right? This is the 2 carbon of my chain, and I got a methyl group on it. And then it's going to have a double bond to oxygen when I break this up. And then I'm also going to have my alcohol that came from here, right? So 3 carbons, just on one end or the other, put a hydroxyl group, and it could look like that. Again, this hydrogen is the one that ended up here. So things kind of got shifted around, but that doesn't really matter that much. You don't have to do that or know that on the test. It's just kind of nice to be able to see it the first couple times so you understand, oh, I didn't need more atoms to do this. Whereas I could do a whole different problem with the same thing. I could start you with that original hemiacetal and add a, what do I want to add? Doesn't matter. Pentanol like this to it, right? So this reaction would be different. So don't worry about this stuff over here anymore. In fact, you could just be thinking about it backwards. Maybe I started with this aldehyde and this alcohol, made this hemiacetal. Now I'm going to make an acetal down here. You just have to understand that I'm going to take out a water. And again, this blue, the highlight's already here, so I'm just going to keep that. I'm going to take an oxygen, a hydrogen, another hydrogen to make my water that I remove. But then I still have all those same carbons. 1, 2, 3, carbon there. This is my carbonyl carbon. So it has to end up attached to 2 different oxygens. One was already there, so I'm just going to keep that in there. And I'm just going to stick with blue. The other one is new. So I'm adding this purple oxygen and all the carbons that it's connected to. So it's connected to 1 this way, 1, 2, 3 that way. So you got that pentanol look still. And this is an acetal that came from that hemiacetal above. So that's what I mean. That's why I didn't want you skipping over that. Because if I start you with a hemiacetal, you need to be able to recognize it and you need to know what to do with it. Does that kind of make sense?
Yes, I understand it more than I did, so I think I kind of got the hang of it now.
You want to try a couple more examples? Have me just put a couple in there and you could send me a pic of a result and I'll tell you if you did it right or wrong. That'd be the easiest thing to do.
Yeah.
So I might actually quit the recording once I've done those and you've drawn them. But otherwise, that's the easiest way to do it. Just practice over and over again. It's like when we were in class and I'd put examples on the board every morning. Okay, what's this thing? What can you do with it? What is it? What are its pieces? So on a piece of scratch paper, if you got a piece, right? If I start you with this thing, so again, it really doesn't matter what it looks like. I can kind of be creative, but I need 2 oxygens connected to a carbon, right? And then I can do whatever the heck I want with it. So this could be 2 carbons like that. This could be a hydroxyl group. This could be that many carbons that way, right? So I'm going to add a isopropyl alcohol to that. And you need to draw a product over here.
Me?
That's fine. Mm-hmm.
That could be one example. I'll draw another one down here. Let's say you have, we haven't used this yet in this context. They have that thing. And I want to add, and let's make this look like this. What product would you get? You got those two things drawn out?
Oh, do them now? Sorry.
Well, if you could draw them out or take a screenshot or something so you can see what they are.
Okay, I wrote them down in my thing.
Okay.
Just to solve them.
So it's going to take a second for you to actually solve it. And I want to add two more. So don't start working on them yet. Just make sure you have all the examples. You got these on the slide so far?
Yeah.
Okay. Again, I can go back to those. But those are two different kinds of examples that we can do. Here's a third kind of example. So let's make it look like this. So I could have that, and I could tell you to break it down. And when I say break it down in this case, break it all the way down into 3 pieces, right? You can skip the middle step if you want to. And then what else haven't we done? Oh, we didn't do, if I draw something that starts to look like this. That thing, and I'm going to add, let's put a pentanol with it. Combine those two things to make a product. So if you try those 4 examples and send me a pic of your results and those look right, that'd be awesome. That's good practice.